All right, here we are at station number 1, the U-Pick pumpkin patch. Though these are beautiful pumpkins that we did this year, and what's exciting about this is that it's a no-till experimental patch. So what no-till means is that we're not mixing and stirring the soil before planting. And typically we do tillage for a number of reasons. One is to sort of increase the aeration of the soil, crack the compacted soil open, allow the air and the water and the roots to penetrate. Tillage is also great for killing weeds and making a nice clean seed bed for when you're going to be planting crops. But tillage also has some downsides. The two main downsides to tillage are that when you till the soil, you're disrupting the fungal mycorrhizae. So in the soil, our main ally is the fungi. The fungi are everywhere. The mycelium are connecting all life together. A little bit like fascia is a connective tissue in your body. Fungus is like the fascia of the soil. And when you go through with a disc harrow or a plow or a rototiller, you're messing up that fascia and really, and also earthworm tunnels, you're destroying the earthworm tunnels, all these things that are just not great about tillage. And so we're looking for certain ways to reduce or even eliminate tillage in our systems. This is a patch where we had sweet corn last year with a cover crop planted in the sweet corn, so that after harvest, we mowed off the sweet corn plants, we had a nice cover crop, we put a tarp on it. So tarping, you'll see it at a later station, is when we use large plastic sheets of plastic to cover the vegetation and deprive it of light and thus kill it without using any herbicides, which is great. So we tarp this patch, and then I put on about 1.5 or 2 inches of wood chips. And you can come dig around a bit for yourself and see what does it look like. You'll notice that under the wood chips is getting to be like nice and dark and like forest soil like. And that's really what we want, healthy, vibrant soil ecology. Also did a great job repressing the weeds, and at the same time allowed for the successful establishment of a cover crop. So in this case, we're using crimson clover, which is a biannual clover species that we're using it to fill the ecological niche that usually would be filled by weeds. Because weeds aren't bad. Weeds play a specific and very important ecological role in protecting the soil, holding the soil in location to prevent erosion, and eventually allowing for the natural succession to go from a field to a forest. And so weeds are a critically important and valuable aspect of the ecosystem. The problem is that they're unpredictable and they tend to grow really fast and choke out your veggies. So in this case, we're using crimson clover as a more predictable and tame version of the weed to fulfill the same ecological niche as the weed would. So this way, we broadcast the crimson clover seed, it filled in any gaps, it choked out any weeds, and now after pumpkin harvest is done, we'll probably put it, we'll mow it off and let it regrow, and then next year we'll have maybe some cabbages here or broccoli, I don't know. So that's one of the aspects that we're doing of research here at the farm, is looking at how do we shift away from tillage, both for bed prep and also for weed control going into the season. So this has been a big success, and I look forward to trying it more in the future and expanding it to different crops, until we hit the limit. So speaking of hit the limit, let's go check the next station.